And we're going to move right along to Charles, who's going to talk to us about Ray.
Hi, everyone. Yeah, sorry, you were breaking up a little
bit. Okay, we can hear you now.
Okay, no problem. So like where I said, my name is Charles. I'm a graduate research assistant at the University of Maryland, studying with Dr. Christine Hartzell, as you just heard from. So today I'll be talking about obtaining a regolith cohesion measurement via induced electrostatic lofting. So prior to lofting, the regolith is charged by the solar wind and photo emission, and they're bound to the surface by cohesion. But the magnitude of cohesion in regolith remains poorly constrained. So to address this, we'd like to exploit our knowledge of electrostatic lofting in order to measure cohesion. Quantifying cohesion can transform our understanding of the geologic evolution of the lunar surface and electrostatic transport on the surface. And also quantifying cohesion in regolith is an important knowledge gap to address because knowing the magnitude of cohesion can tell us the magnitude of a force a dust mitigation system needs to apply in order to clean a dusty surface. So the ability to induce electrostatic lofting can provide a new method of dust removal from spacecraft surfaces. And so we want to introduce the design of the electrostatic sample collection and cohesion quantification system, or ESAC, as pictured in the middle. And how it works is a biased attractor plate produces a voltage difference with the surface, generating an electric field. And this electric field accelerates the charged regolith grains below toward the attractor plate. So the electric field strength can be tuned by adjusting the plate's height and electric potential. While the grains are lofted by the attractor plate, the camera will image their size and trajectory. And since we know the local gravity on the lunar surface, for example, and the electrostatic force on the grains is controlled by the attractor plate, we can back out the cohesive force on the grains.
I guess we'll find out.
Yeah. So the ESAC electric field can also be adapted to force charged grains away from the attractor plate, cleaning off the surface. So once cohesion in regolith has been quantified, the attractor plate potential can be tuned in order to apply the required electrostatic force needed to overcome cohesion, thereby removing dust from spacecraft surfaces.
Charles, so ESAC, you have 1 minute remaining.
Okay, I think I'll finish in time. So ESAC induces electrostatic lofting of charged regolith to measure cohesion, and also to clean dusty spacecraft surfaces, say on the moon or airless bodies such as asteroids. So thank you very much. That's my talk. This research was funded by a NASA Picasso grant. So please reach out to myself or Dr. Hartzell if you have any questions about this. Thank you.
Okay, great. Well, thank you so